trying to embellish it if you're not there yet. Okay. A cubic function, negative leading coefficient. Y-intercept is 0, -3, no turns. So for me, that would be, I'll start with this. I'm also not even going to take marks away if you forgot X and Y on this one. But basically, you want to make sure this is 1, 2, 3. This is 0, -3 right here. And we have a negative leading coefficient, no turns. Okay, so this basically you can make it twist there. So if you want to do one of these, that is fine. But it doesn't have the turns. Like this doesn't go up like that. It just has a, you might think that is a turn, but it is actually not a turn. It goes down and it keeps going down, right? So that's what a no turn cubic looks like. It's either 0 turns or it's 2 turns. There's nothing in between, okay? B, a quadratic function. We're going from Q2 to Q1. Q2 to Q1, right? So it's definitely going to be pointing up. That's the giveaway there. The y-intercept is 0, 5. So we're going to go 1, 2, 3, 4, 5. If you just had a point there and you label it 0, 5, I'm good. Okay? So in this case, no matter how you do it, you want to have it a little offset. It doesn't matter. But it would look something like this. It has to go through 0, 5, and it has to point up. That's it. That's the only requirement. Okay? Mr. Dixon, what if I did say, oh, 1 x-intercept. I didn't read. You were looking and you're like, what is that, Mr. Dixon? We are awake. We look like we're asleep, but sorry. So there, we wanted to touch here once, okay? So anywhere, you make a point there, and in this case, I would do this. Okay, in my case, that's what it looks like. Maybe some of you did it this way. You came this way, touched it once, and then went back up. That is fine. The only requirement is it has to be pointing up, and it only touches the x-axis once, and it goes through y-intercept 0, 5. Not asking for much, right? C, a function with a degree of 1, negative leading coefficient, x-intercept of -4. So I'm going to do C right here. Negative leading coefficient means it's going to drop from left to right. Its x-intercept is 1, 2, 3, 4 right here, -4. So my graph is going to do something like this. Okay, it just has to drop from left to right. You're like, it doesn't go from quadrant 2 to quadrant 4 like you told us. Yes, eventually the ends will end up in those quadrants. Okay, so as long as it goes through -4 here, and maybe you want to be very explicit about it, and you say that's -4, 0 right there, and up here that's 0, 5, you're fine. Okay, so 1 mark for each. If you meet all the criteria, you get it. If you don't meet it, if you were almost there, take off half. Okay, all right, let's do the front. Three marks for the backside. Okay? So for a constant function, the degree is 0. The degree is 0. Number of possible x-intercepts. This one is tricky. It's either none or infinity. If you said none, I'm fine with that. Okay? But if it's right on the x-axis, a constant function would have an infinite number of x-intercepts. Possible turns, 0. And behavior if leading coefficient is positive. So if we're positive, it's going to go from Q3 to Q1. Sorry. I'm thinking linear. My bad. This one has 2 options, right? It positive or negative doesn't really. If the value is positive, it would go from Q2 to Q1. right? If you have a y is 3, it's up here. It's going to go from Q2 to Q1, right? If it's negative, it's going to go from Q3 to Q4. Technically, there is no leading coefficient there, but just if you answer this way, you're fine. Linear, degree of the function is 1, possible x-intercepts 1, number of possible turns none. If you put none, that's fine, 0. If the leading coefficient is positive, you're going to go from Q3 to Q1. If it's negative, you're going from Q2 to Q4, right? So basically, you're doing this. If you're positive, you're going up like that. Half a mark for every single entry. That's how we're going to address this particular one. Quadratic, degree of 2. Number of possible x-intercepts is 0, 1, or 2. Okay. Number of possible turns, 1. If it's positive, it does this. So it's going to go from Q2 to Q1. If it's negative, it does that. It's going to go from Q3 to Q4. Cubic function. It has a degree of 3. Number of possible x-intercepts. It's 1, 2, or 3. Okay, there is no 0. It will cross the x-axis at one point. Number of possible turns, 0 or 2. If you went 0, 2, that's fine. If it's positive, it behaves exactly the same as linear. If you remember your linear, you can copy paste. If it's negative, it does the same thing as a linear would be, the end behavior. Where are the ends ending up? That's basically what you're asking there. So that means that this one is 1, 2.5, right? So every column is worth 2.5. So it's going to be more than what's stated at the top, right? So this would be out of 10. This whole thing is worth 10 marks for that. So I'm just doing 2.5, 2.5 for the first column, 2.5, 2.5, 2.5. So we're at a total of 10 for that table. So just be honest, and you're good to go. If it's not exactly the way it is here, just take marks off. Okay? Copy down the right answer, but take marks off. By the way, sorry, if you want to, for the cubic, if it's positive, it does something like this, right? If it's negative, it'll do something like this. All right, let's keep going. For these ones, you have to use your calculator. And obviously, this one has a degree of 2. You didn't need a calculator for that. The x-intercepts, if you did this right, I'm just going to state them. This is what the x-intercepts are. The y-intercept is just that constant at the end, but you may have used the calculator for it. That's fine. And behavior, since the leading coefficient is positive, we're expecting this. So this will be Q2 to Q1. Range. This is where you need to remember your range, right? For this one, range is greater than or equal to the y value of the vertex. So you have to find the vertex for this one. And so I'm going to give you a mark for that one. So the vertex, if you found it, it's negative 3.13, negative 33.06. You're going to get a mark for that for sure. If you found that, let's say you didn't write it down, you just have that 33 show up here, then I'm assuming you found it, right? So this would be greater than or equal to negative 33.06, squiggly brackets, or if you use interval notation, it starts at this y value and then it goes up to infinity. That's how you would do the range for this particular question. So here's how I'm gonna break it down. We're gonna go half a mark for the degree across the board. I'm gonna give you just 1 mark for the x-intercepts, 1 mark for the y-intercepts. I'm gonna give you half a mark for end behavior, and we're gonna give you a full mark for the range. And that will include, in this case, the vertex itself gets a full mark. So additionally for this column right here. So for this column, it would be 1.5, 2.5, 3, 4, 5. So for this column right here, you're looking at a total of 5 marks if you've done all of that correctly. Next, for the linear, it's a degree of 1. The x-intercept is 0.380. The y-intercept is 0, -3, right? It's -3. The end behavior, my leading coefficient is positive, so I'm expecting this shape, like it's going to go up from left to right. So we're going to go from Q3 to Q1. The range, both methods, in this case it's just y belongs to all real numbers when it comes to the set notation. If you want interval notation, it would just be this. It's negative infinity to positive infinity. And so for this one, you would just get 4 marks for that column, right, for linear in total. Then you've got your cubic. It's got a degree of 3. This one I'm going to type in real quick if you allow me to do that real quick. I should have done that earlier. But I think this one gets into the issue of, so I'm going to graph it. It's actually not bad, but I'm going to try zoom standard. Zoom standard shows me the x-intercepts. I need the y-intercept and the low dip there. So I'm going to decrease my y-min to -50. That's a pretty good graph right there. It's a little, there we go. So to find this one is the problem. Okay, so if you want to find the x-intercept right here, if you want to find that one, it's probably not going to find it if you're zoomed out too much. So enter, enter, enter. It'll just jump to this one, which, let's write it down, it's 40. One of them is 40. And you can kind of tell that it's probably touching there. So you got to investigate. You got to use zoom in, and just go a little bit closer to that. So go in with the cursor, and then just press enter. I think this will do the trick. Let's try again. Second trace 5. Enter, enter, enter. Yeah, now I found it. -20 is the other one. So you zoom in. If you suspect it's happening, zoom in, and then it'll fix it for you. And then you can zoom out again. If you press zoom out, and just press enter, and you just keep pressing enter, and it will zoom out from that picture. And yeah, of course, it's going to mess up your original. Of course, I can't reset it, but Zoom Standard did a pretty good job to get it back. So those are my x-intercepts. The y-intercept is just 0, -16. The end behavior, you can look at this, right? It goes from Q3 to Q1. So Q3 to Q1. By the way, that's always something you can do. Just enter it into your calculator and go from there. Okay? If you're not sure what the end behavior is, and you have the equation, type it in. Range, same. It's all real numbers, and it goes from -infinity to +infinity. Just make sure there are no square brackets anywhere. 4 marks for this one. So 5 and 4 plus another 4 gets me to 13 for this. I'm just giving marks away like it's Christmas or something. So 10 and 13, that's 23. And the backside was worth 3, right? So 23 and 3 gives me a grand total of 26 marks for this AC. $26. Name and last name on there.